You see me have to work, 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 work. You see me do me dirt, 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 dirt.
Today we will be discussing the topic of work. As you may already know, work is the change in energy of a system. It can be represented by this equation. Where W represents work and delta E represents the change in energy. The other equation for work is this. Where F represents the applied force, delta X represents the change in distance, and theta represents the angle between the tails of F and X once they're put tail to tail. For example, if force is going to the left and delta X is going to the right, this creates an angle of 180 degrees. Therefore, theta equals 180. And since cos 180 is negative, therefore work is negative, and then the energy will be decreased. I'll show you some simple work problems involving work.
Hi. For the first example, we will be testing the work done for a 20 Newton force exerted on a cart for 3 meters up a 15-degree slope. Assume frictionless. Come on up to the board and look at the answer. So we have the formula here. All it takes is a plug and chug. The work is equal to the force, which is 20 newtons, multiplied by the change in distance, which is 3 meters, times cos of the slope it's been taken up, which is 15 degrees. And that works out to 57.96 joules. Let's take a look at another example. A 15-kilogram box is slid across the table for 3 meters with an applied force of 80 newtons. However, the force of friction acting upon it is 50 newtons. Diagram on the board. We have our 15-kilogram object. The force of friction is 50 newtons, and the force applied is 80 newtons. Let's make this direction positive. And the displacement is 3 meters.
For this question, we will be using the work is equal to change in energy equation. So, we need to take the force applied energy and subtract the force of friction energy from it.
Let's do the force applied. So, the work is equal to 80 newtons times the displacement, 3 meters, times cos of 0, because we chose this direction as positive. So that works out to 240 joules. For the force of friction, the work is equal to 50 newtons times the displacement of 3 meters with a cos of 180 degrees because it's in the opposite direction, which works out to negative 150 joules. The original equation, work is equal to the change in energy, which is E2 minus E1. Therefore, the total work done on the object is equal to 240 minus negative 150, which is equal to 390 joules.
This problem is probably going to be one of the hardest problems involving work. Let's take a closer look. How much work is done by a 65,000 gram cyclist riding an 18,000 gram bicycle? And speeding up from 18 kilometers per hour to 28.8 kilometers per hour. But remember, you have to convert all the units. We're going to convert the following: 65,000 gram. If you move the decimal 3 times over, it'll be 65 kilograms. Same thing over here, 18,000 grams. To find the change in energy equation, we have to use the kinetic energy equation, which is kinetic energy equals 1/2 mv squared. So before we start, we have to know what the total mass is, which is equals 65 plus 13, which equals 78 kilograms. And now we can just plug and chug. So at event 2, EK equals 1/2 bracket total mass bracket 8 for velocity squared, and whatever that answer is. And for event 1, it's the same thing. EK equals 1/2 78, but now the velocity is 5 squared, and whatever that is. So the answer for E2 is 2,496 joules, and for E1 it's 975 joules. So now to find work, work equals change in E, which equals 2,496 minus 975, which turns out to be 1,521 joules, and that is the total work done.
Third. Coochie down to the socks like I'm Biggie Papa. Baby. Keep your girl head in my Tommy boxes, but run it out.